exercise 3I on spatial patterns, and it's on page 154 of your textbook. Now, spatial patterns, spatial we said just means space or shape or area, right? So it's just saying, well, area patterns, or in other words, patterns that we use or we see visually. In this case, I've got triangles, and they're clearly matchsticks. So it says draw the next two shapes in the spatial pattern. Now the first one is one triangle made up of three matchsticks. The second one, so remember our terms. There we go. Our first term, our second term, our third term. So what's our fourth one going to look like? Can you describe it for me, Brody?
So it's just going to be an extra triangle.
Good. So it's going to be one. Oh, I am very good at drawing triangles. Trust me. There you go. Hopefully yours is a little bit better.
Very nice.
But it should be 4 triangles. Now, what's the next one going to be? Oscar. Good. It's got to be 1, 2, 3, 4, 5. Once again, I hope your pattern's a little bit better than mine. Now, that's the easy part. Now we have to fill in a table. Now, what is that table looking for? What do we have to fill in, Xavier?
Number of triangles.
So we got the number of triangles, so that's in each one. We're looking for the number of sticks. So in the first one, how many sticks did we need? 3. How many sticks did we need for the second one, Xavier? 6. So what did you do?
I doubled.
You doubled it? Okay. Taylor, how do I find the third one? How many sticks in the third one? Okay, what do you get? 9. Alright, Caitlin, what did you get in the fourth one? How many sticks do you need to make the fourth one? You need 12. Okay, I'm going to write 12. And lastly, Kenta, how many sticks do I need to make this one? So we've got 3, 6, 9, 12. The next one will be 15. So off the bat, what's the pattern that you guys are seeing? Okay. Henry, what pattern do you see?
What's it called? The number of triangles, factors.
Oh, I like that. I like where you're going. So the number of triangles, because we're looking at it this way, aren't we? So 1 and 3, we're seeing 2 and 6, we're seeing 3 and 9. The number of triangles is a factor of the number of sticks required, Georgina.
Technically, you're adding 3
Okay.
on top of each.
Does anyone remember what it's called when I'm adding a number each time? It's a common...
A common multiple.
No, that's multiplying. It's called common ratio and multiplying. Lucas, do you remember? Common difference is correct. So we add 3 on each time. Now, that works as well. The next question is when it gets a little bit interesting. It says, describe a rule connecting the number of sticks required to the number of triangles. Now, there's actually a few ways you can do this, but there's a straightforward way. Lucas, do you have one of the options?
Yes. Every triangle you add 3 sticks.
Good. So, if I had one triangle, it requires how many sticks?
3.
Good. So what I'm going to do is I'm going to write a rule. You guys might have seen this as something called an equation. I'm going to write it in words though. So the number of sticks, and I want you to copy this down, thank you. Number of sticks equals 3 times number of triangles. So the number of sticks equals to 3 times the number of triangles. Can you see that from over there, Brody? Okay. Now, does that work for each one of our examples? Let's try, just in case. So let's pick one that's pretty straightforward. If I have 2 triangles, so the number of triangles is 2, what do I have to multiply by, Farah? 3, and that gives me 2 times 3 is? Is that 6? Perfect, so that works. Let's try one bigger. Let's say I'm going 5, so the number of triangles is 5. Kenta, 5 times 3 gives me 15, which in that case, is that correct? Awesome, so it works for our pattern. What's the point of making a rule? If I've already got that table there, what's the point of making the rule, Taylor?
If you have larger numbers, it's easier to
Perfect. If my next question was, let's use the table, whatever, or use the matchsticks, whatever, to find how many matchsticks you needed to make 1,433 triangles. Would you want to spend what is essentially an entire day putting matchsticks out on the oval to try and make 1,433 triangles? No, you wouldn't, Taylor.
Just times it by 3.
Good, use the rule, and our rule says times it by 3. So it says in the next one, now we're not going so extreme as using 1,433, but it says use your rule to predict how many sticks would be required to make 20 triangles. So our rule says number of sticks equals to 3 times the number of triangles. So we're looking for the number of sticks. Number of sticks equals to. Now what do I replace, Taylor? So what information do I have in this question?
Give the 20 triangles.
Good, we're looking for 20 triangles. So instead of writing number of triangles, I write
20 triangles.
good, 20. So that equals to 60, and therefore, if I wanted to make 20 triangles, I would need 60 sticks. Make sense? So we're using that rule. What happens if I want to make, let's say, 1,433 triangles?
How much was it? Oh,
Yeah, Noah.
you need 4,299.
I need how many, sorry?
4,200.
Did you actually calculate it?
Yes.
Okay, so what you would do is you put in the formula, same idea. You go 3 times by the number of triangles. In this case, the number of triangles is 1, 4, 3, 3. Now, Noah, you're telling me that you got what, sorry?
4,299.
Yeah, I got
4,299, was it? I'm going to take your word for it, 4,299. So, as long as you follow that rule, we can find this number of sticks for anything. In this textbook, the exercise, typically we use sticks or matchsticks or whatever, but in the same idea, it doesn't matter what it is as long as it follows that rule. Do I have any questions? Awesome, I'll let you guys get started on exercise 3I. Is it 3I? Yeah, it's 3I. The questions start on page 158. If you have any questions, let me know.